everyone. Welcome to AI Thinkers. If you're here for the first time, we are a study group outside college. That's what we used to call ourselves. We're all AI practitioners. We all talk interesting topics around AI and like different challenges that you're facing right now regarding like evals, SDKs, cost of APIs, RAG pipelines, memory, cool new papers, all sorts of things. Yeah, welcome everyone. I think we're getting ready to get started now. And this event is also being live streamed. If you want to send it to your friends, ask them to check out Austin Tech Live. Austin Tech Live YouTube channel has this live stream going on right now. And we have two sponsors for this event. It's Google and Comet. I'll first let Google introduce themselves and give a small presentation.
Awesome. I wish I had some background music as I'm getting my thing set up. Let's see. Awesome. I think we're ready to get started. Good evening, everyone. My name is Vibha, and I help startups build and scale on Google Cloud. In my everyday, day-to-day interactions, I get to speak with lead engineers, development teams, and really get to know the kind of use cases that you guys are building on the ground, some of the tools that you're evaluating, and that gives me a great deal of insights into your experiences and the sort of capabilities you're looking for, right? So yeah, I hope in this presentation, basically I'm trying to walk you through some of the latest of Google's innovation, especially on the AI side of things, right? So yeah, before we begin, I'll get the quick mandatory speaker introduction out of the way. My name is Vibha and I'm a customer engineer at Google Cloud. Basically work in the early stage startups team, so get to talk with startups on a day-to-day basis. Been at Google for a little over 3 years, working with both startups and enterprises. I also have my colleague with me, Rushi. That's Rushi. Yeah, he is also a part of the same team as me, the early stage startups team, and he does cover startups that are based in Texas. So any use cases, anything that you want to talk about, and if you're part of the program, you most likely might be talking to Rishi. So yeah. Coming back to sort of those day-to-day conversations, some of the recurrent themes that keeps coming up is sometimes when I talk to ML engineers, it's about, hey, how do we sort of streamline our ML ops operations? When we speak to developers, it's like, hey, for the different use cases, which is the right model, right? And sort of finding that balance between performance as well as cost, because we know that cost can be very important for startups. And also when we sort of create those chatbots and agents, sort of making sure that the responses that are generated are actually factual and are grounded, right? So all these sort of challenges that we see, it would be great to have a sort of like unified AI platform that sort of forms the foundation of all these challenges, right? And that's where Vertex AI enters the picture. So Vertex AI was sort of aimed to be this unified ML platform, basically helping people develop, scale, and deploy their ML models as well as AI applications. Now, Vertex AI has been around for a while. It's not something that just came up just with the Gen AI hype. It was initially sort of meant to be this one-stop shop ML platform for teams of varying levels of expertise, right? So whether it was like using the readily available ML APIs, to using your data to create ML models using AutoML, or if you wanted to like create the custom code and build models from scratch, having a sort of managed infrastructure for it. That's where like the collabs and workbench comes into play. So that's where Vertex AI was sort of aiming to help out. But of course, with the Gen AI models, we also have things to offer on that side of things. And I'll sort of walk you through that, right? First off, Model Garden. We do realize that there's no one model that is perfect for every use case. And so basically, this is sort of like a one-stop shop for leveraging all models, right? Whether that's Google's first-party models, both Gemini, Imagen, Veo, Lydia, as well as our embedding models, or whether that's partner models. So say, for example, the Claude models from Anthropic, or even open models as well, right? You have the option of like sort of self-hosting that on Vertex. So Model Garden gives you all those options. Moving on, we have the Live API. Now we do have a bunch of customers who are like, hey, we want to have, we have use cases where we need that voice interaction, a two-way voice interaction. So the Live API basically enables like a low latency two-way voice as well as video interactions with Gemini. And it also sort of lets you sort of interact with the model, and you can interrupt the model using your voice commands, right? So sort of simulating a very human-like conversation. Then we move on to global endpoints. Now, a lot of Google and partner models, which are available on Vertex AI, they are sort of exposed as regional endpoints. And so the aim with global endpoints is to sort of cover the entire world and provide higher availability. I'm sure a lot of you might be familiar with like the 429 errors, those pesky little errors. But with global endpoints, you're basically trying to leverage Google's global infrastructure and with that automated capacity-aware load balancing, so that it sort of evenly distributes requests, and it sort of significantly brings down the 429 errors that you're experiencing, right? Just a small little change in the code. You would just type in global at location, and then, yeah, you get to leverage global endpoints. Yes? Also, I just have 10 minutes for my speech, so we can take the question post the thing too, right? Moving on, URL context. Now this is like an experimental feature. Basically lets you provide URLs as additional context to your prompt. So basically, once you provide it, it retrieves the content from the URL, and it uses that while generating the response, right? So another thing that we've seen customers leveraging. And yeah, moving on, we do sort of realize that with a lot of models to sort of get the behavior that you want out of it, there are a few things that you might have to do. This is sort of like a flowchart from least effort implementation to the most complex implementation. First is, of course, our prompt engineering, just sort of trying to experiment with like, hey, which version of the prompt sort of works best? Either like, making the instructions more specific, adding examples, that's where like the one-shot and the few-shot prompting comes into play, or even, experimenting with the model parameters, so like changing temperature or more top P or top K. In most cases, some permutation or combination of these changes sort of gets you the results. If that doesn't, then you sort of move on to supervised tuning, right? Or you can also try out like distillation methods, and finally, if you're open for it, a full fine-tuning, but we have seen customers do this at least on the open models, right? So yeah, that was a lot about Gemini. We do also have a bunch of like the multimodal models as well. We have Gemini 2.5 Flash Image, Imagen 4, VO3, Chirp, and Lyria 2. So this is, hopefully I can play the video. I promise the video has sound, which I'm not able to play right now. But that is one of the major updates from VO2 to VO3. So with VO3, we're now able to create videos along with the audio. That was sort of, that wasn't a feature in VO2. And it has a much more stricter prompt adherence. And so like, a lot of customers have leveraged VO3 for a lot of their production use cases. Moving on to Imagen 4. Not sure if you guys have tried the previous version of Imagen, but anytime you had to create like images with text, it would a lot of times create this very hieroglyphic language, which you could not even read. We're like, hey, it was supposed to output English, what is this language? But you're now able to create like really good images that has text with Imagen 4. Comes in a few flavors, Imagen 4 Ultra for higher quality images, and Imagen 4 Ultra for like those very low latency workloads, right? You also have Lyria 2 for generating music, and am I able to play the music? Don't think I am, but yeah, hold on. think it got stuck. It's okay, it's fine. Just skip to the next slide. No worries. Apologies for the technical difficulties. But yeah, moving on, we do realize that a lot of the conversations right now is about agentic this, agentic that. From a developer platform perspective, we do have the ADK, which the Comet team is actually going to be demoing a very cool use case using ADK for just deploying and like for creating agents. You have Agent Engine that provides you a runtime for deploying these agents. And then you also have something known as Agent Garden, which is basically like boilerplate code for very common use cases that you can sort of use and then build on top of it, right? Next is a Gemini CLI. Basically brings you the power of Gemini to your terminals. Also had a bit of traction on that front where customers are using that to debug issues, create test cases and stuff like that. And then sort of lastly wrapping it up, to now host your AI applications, what is like the way that a lot of people are doing it? Sometimes, Cloud Run sort of provides a really great platform for hosting these AI applications. You just sort of containerize it and push it, especially the fact that Cloud Run also supports L4 GPUs. That's something that a lot of our customers have been leveraging. So two common patterns that we are seeing is either your models are available on Vertex or you've hosted a model on GKE and then you're doing all the orchestration on Cloud Run, or you can sort of host those models on Cloud Run with the help of GPUs and also have the orchestration within Cloud Run, right? So these are like two model patterns that we've seen. But yeah, that was just a very quick walkthrough of sort of what we have going on at Google right now. Here are some resources. There are GitHub notebooks, there are code labs, there are also Cloud Skill Boosts, like courses as well. And yeah, I think I'll also be sharing a QR code for we have the Google for Cloud, Google for Startups program as well. Sort of give out credits, especially if you're building with AI guys. So I'll try to share that as well. But yeah, thank you.
All right, so I can take questions. Anyone has any questions? Yeah.
I just had a basic question. How is privacy handled on Vertex?
In terms of like the data being handled and stuff?
Correct.
Yes. So basically, Vertex AI, because it falls under Google Cloud's terms and conditions, is sort of Google Cloud is supposed to be like your enterprise, way of implementing solutions. So we do have like a zero data retention policy that states that Google does not use your data to like train the models if you're leveraging the models out of Vertex AI, right? We also know that there are a lot of customers who use Gemini out of another platform which is called AI Studio. Just wanted to clear out that those are two very different platforms. And that's why a lot of my conversations actually with a ton of startups is like, hey, when you're using Gemini, we advise you to use it out of Vertex AI because it does offer that enterprise-grade compliance and security and privacy. And yeah, we don't use the data to uptrain the models.
Okay, and so are you even looking at the tokens at all, or?
Sorry?
Are you even looking at the tokens at all?
That's not stored or anything, yeah.
I think that's when they don't look at the data, right?
So that is when you use Gemini out of AI Studio. Once you're on a paid tier, we don't use the data to uptrain models, but if you're using the free tier, then that's not a guarantee that we make on AI Studio, which is why, again, especially if you want to be compliant, a lot of my conversations with customers is like, hey, please move from AI Studio to Vertex, and please consume Gemini out of Vertex AI. Sorry? I believe it is, yeah.
Well, I actually had a slightly,
So I had a slightly different question, but when he asked his, it provoked a little bit of uncertainty regarding the model garden.
Mm-hmm.
Now, of course, there's a selection of models within that garden, right?
Mm-hmm.
First, perhaps I wasn't paying attention, but I don't know how using Vertex AI it's selected for a specific task. Is that a manual thing that you dictate on your behalf, or is it something that there's, you said, hey, I need something to complete this, and it's selected for you? The other question, the more important question actually, is that you could not technically guarantee privacy because each of those models have their own stipulations regarding which data is to be used for training. And in fact, if you have your own corporation, you actually have to sign or at least take note of all the logs that you have or the interactions that you have on an enterprise level between, or conversationally between you, the people that comprise your enterprise, and the LLM themselves. So that would actually present a conflict of interest on behalf of a person who's evaluating, hey, is Vertex AI truly for me? How would you all address that?
So I would say on the first part where you're like, hey, how do you know if it's getting used out of Vertex versus, am I understanding that right? Like, it was like, hey, how does it select, or I don't think I...
Well, I don't think I got a good understanding of the first part, which is that, like, okay, so it's like, I say I want to use Vertex AI, right?
Mm-hmm.
So, as part of Vertex AI, one of the core features is the model garden,
Mm-hmm.
right? He just presented the question of whether, hey, I have privacy concerns, especially pertaining to the nature in which my training data is shared amongst the LLMs and perhaps Vertex AI as a whole, right? With that being said, if he's a business owner, for example, in order to protect his intellectual property from it being essentially stolen from any of the LLMs that are comprised of this garden, their rules independently, you cannot guarantee that Vertex AI, we can protect you from that. That's what he's saying. How do you counter that from a enterprise perspective? As in, like, if I'm an enterprise customer, like, why would I essentially put the very foundation of my company's defensive moat intellectually? Why would I put that on the line? I mean, you can't definitively guarantee that for me, or at least as you presented it now. Or maybe I'm getting something wrong.
Yeah, I mean, sounds like a legal question. No, not a legal question. So maybe you're getting confused between AI Studio and Model Garden. So AI Studio is a developer tool where we may use the data if you're using free tier. But with Vertex, we don't. It's in our terms of service agreement, which you can check, read, challenge as well to our legal team. And I think your second question was, which was very valid, for logging purposes, we might log those things. But there also we give you an option to opt out of logging. But then if you do that, if you want to troubleshoot something, you won't be able to find any logs. So yeah, I mean, that's an option. If you don't want logs, you can opt out from that as well.
See, but even within the experience of using it, if you don't subscribe to logging,
Yeah.
there's no basis for inferencing. If I'm working on something for days in or even weeks in, it's like that conversation history is effectively, it's not the same. I've known you for 3 weeks, and I've learned certain things about you. But then I basically have to relearn you every single day. That's basically what you're saying. And that comes at an unquantifiable detriment to my productivity on that platform. Did I frame that in a way that's understandable?
I mean, yes. But if the terms of service says we don't use it, then, what other explanation you expect
Okay.
from us?
Let's just carry on.
Yeah.
Let's just carry on.
Yeah. Okay. Any other questions?
Just in general, I saw one of your slides mentioned MCP servers, but I'm curious, maybe there's 2 questions here. Number one, what is if you are a tool, basically, and you want to present yourself as a tool for agents, like how would you be discovered on Google's platform? How do you get on there as like a tool, maybe that's like in front of people's faces? And then maybe second is like, is there a standard where you think tools are going? Does Google have a house view on that? Like what the ultimate predominant standard will be for a tool, for an agent tool call?
So basically, like tool definition on GCP is that?
Well, like in other words, I mean, if you just think about all these MCP registries, and it's just like, oh yeah, here's like a million things your agent can connect to. Like, what will that ultimately? What will that infrastructure be? What will this? Are we going toward that standard? Because I've heard lots of drawbacks with MCP, but I'm curious if Google has a house view on that. And then a separate question, like if I wanted to get my thing from Google AI like agent developers, how would I do that?
I'll try to rephrase that maybe, and correct me if I'm wrong. One, he's looking for a marketplace for his particular tool that he or she might have built, right? And how does that marketplace in Google work if such a thing exists? Secondly, is MCP the future? What is Google's take on it?
Yeah, so with respect to tools, I haven't seen a protocol or a standard yet coming from us. But for agents, you're already aware we have A2P, and then we also recently launched a payments protocol where agents can actually do payments as well. And then Anthropic came with MCP already, and we also support that. So for tools, not yet, maybe soon, but I'm not aware as of now. And marketplace, so for agents, we have marketplace as we speak. But for tools, not yet. But again, if we have it for agents, I have no reason to think that why we won't have it for tools as well, because tools are also very in demand, I would say, concept, and people use that with MCP servers and agents. So maybe soon we will have that as well.
All right, give a round of applause for Google. Thank you very much for sponsoring us. With that, I welcome Comet and Vincent Koch, and he'll introduce himself and comment.
Hi everyone. Hi, my name's Abby. I'm an AI developer advocate and growth engineer at Comet, and I'm here with my colleague Vincent Cox, as I was already introduced to as our old colleague.
I'm also a researcher and developer experience at Comet as well.
Awesome. So we're going to do a demo for you tonight about the Google ADK and how to log and then also evaluate that using OVID. go through the slides, which I'm going to keep really short, but I just want to provide a little bit of context for what this is about to show you. So if any of you come from a software engineering or DevOps background, you're probably really familiar with observability. But in AI, it's a lot more complex because LLMs are non-deterministic.
Can you put the microphone here?
Yeah, sure, sorry. So if you come from a software engineering or DevOps background, you're probably already familiar with observability, but in LLMs, it's going to be a lot more complex because LLMs are non-deterministic. So that means that traditional approaches like hard-code logic or like a try-except clause, it's not only not going to scale, but it's not going to work because you simply can't anticipate every possible output of an LLM or an agent. And it might seem very intuitive at first that LLMs are not deterministic since the output is the sampling from a probability distribution, but it actually runs a whole lot deeper than that because even when you set a temperature to 0, which theoretically makes sampling deterministic, LLMs still will produce different results. So, there we go. Thinking Machines Labs recently published an article. It's gone a little bit viral, so maybe you've already seen it, maybe you haven't, but I just wanted to highlight their recent research shows that non-determinism may actually be due to how kernels behave when batch sizes and inference loads fluctuate. It's not the topic of discussion. I'm not going to spend a lot of time here. But the point is that the non-determinism in LLMs runs very deep. And the same inputs won't necessarily yield the same outputs every time, meaning traditional evaluation metrics and methods that you would use in software engineering simply don't work for LLMs and therefore agents. So some other reasons that monitoring and evaluating LLMs is hard is that many AI tasks don't have a single correct answer. So if you think of, for example, open-ended tasks like summarization, content generation, reasoning, you may have multiple outputs that are equally valid. The same meaning can come from different versions of language, and you can say the same thing in many different ways. So simple n-gram metrics, regex, or pattern matching is not necessarily going to be helpful because it's not capturing semantic meaning. Even if you consider some widely used evaluation metrics that do capture a level of semantic meaning, things like relevance, coherence, conciseness, those are all subjective. So when we talk about a ground truth for relevance, what we're really talking about usually is a single human's point of view, their annotation, or an LLM, and human expert annotators often disagree, right? So that's a whole problem in and of itself, but human feedback remains crucial, but the word ground truth is very misleading. And the point being that capturing what good looks like is especially challenging when you have no single correct answer, ground truths are subjective, and finally, AI systems also drift over time. So you have model updates, you have prompt changes, you may even have like subtle shifts in context handling, and these will all change your outputs, even if the application code that you've written and that you've run before, even if that hasn't changed, that can alter the output of your application. So this is a sort of funny example that went viral in 2023 when a chatbot for a Chevy dealership agreed to sell a user a car for $1. And the funny part about it is that this user actually took the dealership to court and won. And they were forced to give them a car for $1. My favorite part is apparently no takesies backsies is legally binding, so remember that. I know I will. But the less funny point of this is that there are real consequences to these systems making decisions, and it's really important to evaluate your systems. And in order to evaluate your systems, you first have to be able to see what's happening in them, and collect the data that will allow you to start evaluating. I think the last last or second to last slide, monitoring agents is even harder than monitoring LLMs. Why? Agents just add to the complexity of LLMs, right? So they're multi-step workflows, you have more moving parts, more failure modes. You're using external tools, so you have silent failures, you have external dependencies. You're chaining LLM calls, so when we talked about non-determinism in a single LLM call, once you start chaining those LLM calls, you're just compounding the potential error and variability, which makes it even more difficult to predict what's going to happen. There's dynamic memory and context, so sometimes intent can drift, prompts can drift, performance can degrade over time. And ultimately, when you're evaluating, you're not just evaluating your outputs in agents. You're evaluating the entire process along the way, right? So if your agent has output the correct answer, but for example, it's called 35 tools when it really only needed 2, you have a serious problem because you are going to be using a lot of extra compute and probably have a lot of extra latency. Likewise, if the reasoning your agent used to get to its output is, for example, racist or otherwise harmful or problematic, you have a serious problem. You can't deploy that application to production. So that's why monitoring and evaluating agents is very, very tricky. And now for the part I'm sure you're much more interested in, the actual code. Vincent is going to walk me through. We have a recipe agent example. Basically, the application will ask us for some ingredients that we have in our fridge. When we input them, it's going to give us that recipe.
So the Google team are talking about like how you can write agents. So using Python, we can use a framework known as Google ADK or Agent Development Kit. This is provided by Google, so this allows you to write agents. I'm going to share this code with everyone afterwards. I'm not going to go through in detail, but I just want to explain a couple things here. So we're going to use OPIC, which is the platform that we're using. We're able to import that package and use the integration that comes with ADK, but also import the packages required for Google. Essentially, what we're going to do, we're going to define a number of agents. So we've got an agent here, it's using the Gemini, it's a recipe suggestor. It's going to take the ingredients that we're going to feed it, it's going to come up with a recipe. We're also going to have a recipe researcher that's going to look for variations, give us some context. And we're also going to have like a master agent that's essentially going to make sure that the sequencing of the agents, the steps they go through, one information pass into another sort of works. And then just some scaffolding for us to actually take that data in. So just 200 lines, you could probably make it less, make it quite neat and small, but it's just to show you, like from a code perspective, there's not a lot of complexity. A lot of that complexity is handled for you by the frameworks like the ones provided by Google. So to kick us off, I'm going to run this code. And I would like some, perfect. Can someone throw me some recipe ingredients that you would put in food?
Tomato.
Sorry, one at a time.
Tomato.
Tomato.
Garlic.
Tomato, tomato.
Nutella.
Garlic. I'm not going to put Nutella because there's a fun one I like to put. One more.
Onions.
Onion, and I put hay. We'll see what happens with the, ignore the error messages though. It's just okay. So it's come up with, what does it come up with? 15-minute cook time, 2 medium ripe tomatoes, onion, black pepper. It's got the gummy bears. Wow. So you cook it up, you serve it. It's actually disgusting. Haribo tomatoes with sandwich. Actually, you know what? That actually might work. For relish, this is the first time I've done this where I actually looked at it and I'm thinking that might actually work. That might actually work. Wild enough that it might actually work. And then it passes to the next agent. So it starts to give us some context, give us some nutrition, give us some tips, some variations. You probably leave out the Haribos. And you kind of see how that works. So the agent framework obviously logs a lot of that data. And the platform we work with is called Comet, OPIC, which is part of Comet. And you can get started for free. You can sign up to an account. You can get a key. You can link it with your code. And everything you saw gets logged and pushed up. So that conversation we just had, if I go into my Google ADK project here, that conversation gets logged. So that one conversation that we just had, all these little steps that you see sort of get put together. I'm trying to find, here, sorry. We're making a lot of changes. So that's what it looks like. The actual agent execution is we have a recipe master agent, which talks to which passes that information to the recipe suggester, which comes up with the research, and that actually goes off to the internet and finds nutritional information and looks for recipes and things like that. So all that data gets collected. As you can see, there's like a lot of steps going on in there, right? So any one of these little steps in between, something can go wrong. It could take a lot of time, it could cost a lot of money, use up a lot of tokens. And this is where, imagine you start to do this at scale, it becomes quite complicated. Now, the last thing I'm going to quickly show you, because I don't want to bore you all and take up a lot of time, I'm sure there's questions and there's demos after this, but we can use large language models like a Gemini model with an instruction to basically take all the inputs that we've given it that's been sent here to look at it from a different combination. So one of the ones I'm using here is look at it from a taste appeal. How nice do you think this is going to taste? Look at the ingredients, look at the seasoning, and look at that. So we can actually tell a judge or look at another AI model, an agent separated, to look at the whole interaction and kind of give it a score out of 1 to 10. So if I go back to that specific run that I did, I was having problems with this. You can see it gave it a score of 3 out of 10. And if we look at the feedback score, it's going to say the concept of Haribo tomato presents a significant culinary challenge. I think that's it. So, but like, you can have a lot of these conversations happening in your agents or things happening in your agents. These scores allows us to quickly give it a score. It could be true, false. It could be 1 to 5, whatever your scale looks like, and then quickly allows us to just dissect those particular use cases that have gone wrong. It could be a customer's or your internal testing, and then allows you to then go through a refinement process. I was finished anyway, so yeah. Thank you.
Can you evaluate any step that called an LLM, or you only can evaluate the last one?
In essence, yes, you can. Any step can be evaluated. The whole chain can be evaluated, and you have a lot more control when you're using the SDK to run the evaluations in the code, because you can call specific evaluations. We can do like, does this LLM come back with a number that's higher than X? So we can write specific rules actually in the Python code or the TypeScript code. However, in the UI one with the judges, it's a bit more, how should I say it, controlled around some of the specific tests that you can run. Because this runs in the cloud. So imagine you have a chat application, it's running with your customer, it's linked with OPIC, your code's running. All those evaluations are actually happening on our platform. And we run the scores and we kind of give that to you in a dashboard.
Thank you for the demo. I was wondering, where can I see a cost tracking for running the agent in the system? I see the number of tokens and the latency showing.
Yeah, you just found the bug. We'll have to update it for ADK. Honestly, what happens is a lot of these frameworks change quite often. So we have to constantly keep on top of it. So that could be a specific model of Gemini with that specific framework. Normally what happens is we know based on those tokens and that particular model, what the actual cost is going to be. And we'll actually put a $ sign next to each one of these and then the total one for each run. And then when you go to the metrics, you'll also be able to see like how much did it cost for the entire day, week, month, and something like that as well. But I'm going to log that with my team and get that looked into as well.
Okay, thank you.
Wouldn't you need to track both input and output tokens because output's more expensive?
We track all of it.
Okay, just tokens.
What do you mean? Sorry. You see the data as well. So you can see the actual output coming from the model, the number of tokens, the cost, everything.
Okay, I see it now. Perfect.
Yeah.
Hey, thanks for the demo. So what do you bring different from line graph? So I've been using LangChain, and then under the hood, line graph also provides traceability and observability. Just curious, how is this different from line graph?
So in essence, each agent framework has its own flavor of doing things. You can take line graph, which is another type of way of declaring tools and interacting tools and doing sequential tasks. You can take line graph and you can put a Gemini model in it as well. I know this is getting really confusing, but we do support line graph as well, and you will see similar, if not the same, sort of output. It's just some people prefer to use some frameworks over others because of the tooling and the way the connections work, or it could be the ecosystem that they're using and the way it writes. I have my own personal opinion on that, but I don't want to bias anyone around which one you should use. But we tend to find that particular models, like for example, Gemini models will obviously be first class when it comes to running within something like, say, Google ADK. And obviously if you're using, working with a team, you're likely going to get better support and better coverage around sort of features as well.
Thank you.
think also with LangGraph and LangSmith in particular, they work really well if you're already using the LangChain ecosystem, but then you're tied into kind of sticking with that because once you leave that ecosystem, things can get complex and like pretty hairy. It supports other frameworks, but it can get hairy.
Okay, so if you're using ADK, then I don't think it's that big deal.
It would probably be, yeah, it would probably be better to use something that wasn't so reliant.
Thank you.
I just wanted to make sure I understood. Is this purely observability, like post-analysis, or is there a way to intercept? Like if a bad call is going out, can we intercept it and stop it from going back? Like if someone just put in 4 bomb ingredients instead of 4 food ingredients, and it somehow finds a way to do that, would you be able to intercept that and stop it? Is that not your?
Yeah. So traditionally with tracing and observability, you are observing, as the word would suggest, right? Like you're just consuming the logs of what's happening. But on the client side, a couple of things happening. Like the client, obviously, you can run the evaluations asynchronous. You can run it as it's happening, like really small evaluations. And we do have some what we call guardrails that you can deploy that sort of avoid that. I would actually say the Google team with the Gemini will probably have some features around guardrails at the model level that you can also do when you sort of deploy with Vertex. Correct me if I'm wrong. I can't remember off the top of my head, but I'm pretty sure Gemini through Vertex has some features around this. So there's controls that you can put at like literally like every step of that sort of ecosystem of that data going through. Or in some cases, yeah, it just depends how much control you want to put, and that's going to obviously cost in terms of latency and processing time. You know, it just depends on the control mechanisms for that. But obviously the first step would be to kind of make sure you're tracking all the conversations, because without that, you wouldn't even know something is going wrong in the first place. Or if you had tons and tons of logs, yes, you think something's going wrong, but then it's a needle in the haystack to try and find it. Like no one in your team is going to go through a million chat conversations to find the one thing that went wrong. And that's why the evals come in to help you try and at least identify some of those use cases.
Thanks.
All right. Unfortunately, if you have more questions, ask Vincent and Abigail later. Thank you very much for the presentation. Give them a round of applause. Thank you again for the sponsorship as well. Yeah, we have one speaker here, Josh. So I'll let him introduce himself. Are there other speakers here? Okay, cool. Any more speakers? Okay, yeah. Then
I have like a 10-minute PowerPoint slide, or I have like a 4-minute code overview. 4-minute code perfect. It's not much code, but it's just pretty interesting. We'll go for it. Why not? You guys hear me okay? All right. So this is actually my first time at AI Tinkers. I really wasn't sure if this would work out, but it said you can do research as part of your presentations, so I decided to present research. My name is Joshua Barron. I'm an applied scientist at Amazon here in Austin. I graduated with my master's from UC Berkeley in robotics and AI, and this research was actually done outside of my work, so it's not completely with Amazon, but they did let me present it, which was very nice of them. The research is actually on the characterization of memorization and generalization in pre-trained language models. There's the repo. If you start, I'll give you a high five. And if you want to like run some of the code, here it is. Again, this would be really, really fast overview of some research, but the general idea is that we took the NanoGPT repository from Krathi, which is fantastic, made some modifications to specifically test for and tease out this generalization versus memorization of the model. To test for generalization, we made a math data set where we have very simplistic addition and subtraction from 0 to 9. So 0 plus 0, 0 plus 1, all the way to 9 plus 9, and then the subtraction version as well. However, we hid, or basically withheld, all 5-7 combinations. So no 5 plus 7, 7 plus 5, 5 minus 7, and 7 minus 5. This, what it's going to kind of do is that basically we're kind of playing around with the idea that during training, these models see everything, right? They see everything, but can they generalize to something that they haven't seen? For example, think of like medicines. They've seen probably every single equation of a medicine. Like this plus this plus this equals Adderall. I'm sorry. Advil. Freudian slip there. Advil, or this plus this plus this is Tylenol, right? But maybe there's something between those two that it doesn't know, and we could generalize to that if it never saw that in the training. So that's why we withheld those math cases, those 5-7 combinations. For memorization, we have capital cities. Those are your, okay, capital of X is Y. Capital of France is Paris. And this is important because no one would trust a model that hallucinates very simple questions, right? If it says the capital of France is Toronto, no matter how well it does in evals, people would be skeptical and probably wouldn't use it. And this incentivizes a lot of memorization training of these models. And so we're trying to characterize, does training for memorization actually impact the ability to generalize? We test this through 4 size models, and we actually had to modify some of the NanoGPT stuff to make the models this small. We're talking very, very small. And basically we have the smallest model, which is like our N14, and then our 28, 56, 30, basically just kept adding to it, where it's 1 layer, 1 attention head, no regularization, and then we also threw in a regular GPT-esque, like multi-layer, multi-attention head, and we trained all these 4 models on those data sets. The first result we got was kind of fascinating, but not that surprising if you do a lot of traditional machine learning, where only the smallest model was actually able to generalize to those 5-7 combinations. This is because, again, the model doesn't have enough parameters to memorize the math it's seeing. And so for it to actually reduce the loss, it has to find an underlying function. The bigger models, they have plenty of parameters and plenty of representational capacity to just memorize all the math that they're seeing. And so they can memorize it, which is much easier local minima, and so they quickly memorize the math they see, which means they never generalize to those withheld 5-7 combinations. And we thought this was actually surprising. We were actually trying to prove something else, and we found this, and we're like, oh, we'll work with this. Now, when we use those same models on memorization tasks, we see here that the model that didn't have enough parameters to memorize math definitely doesn't have enough parameters to memorize the capital cities. And we got 8% accuracy. With bigger models, they all had no problem memorizing all those capital city facts because, again, it can represent all of that in its parameter space. The other interesting finding was that, well, if we introduce both tasks, so if we concatenate the math and the facts tasks, or data sets, what happens? And what we find is that the introduction of a memorization task basically suppresses all of the generalization. And we had, of all these models, not a single one got any of the 5-7 combinations correct. The models that were big enough to be able to get the capital cities correct were also big enough to just memorize the math, and therefore did not generalize to those 5-7 combinations. And then with the multilayer transformer, again, we tried that, and it immediately memorized everything, including the math, which meant it was not able to generalize to those unseen cases. For code, I trained all these on my desktop, which is much more powerful. But luckily, because of the magic that PyTorch is, I can run these on a MacBook. Or at least run the trained versions. Let's see if I can make this bigger. Is it okay? Okay. So this right here is going to be the smaller model, the N14 model. That, again, this is the only one that was able to generalize to those withheld cases. And it gets correct, which is fantastic. Now, everyone kind of says, big models are great, but when you try the big model that memorize the math, it gets it wrong. And what's interesting is that you can really tell it's memorizing, because if I increase it to a model, to a number it did see, it gives the same answer. So again, it's just saying like, okay, I know what roughly goes here. And it's, again, going for the easiest local minima, which is memorization, which is immediately possible when you have too many parameters. For the actual code itself, I mentioned there's a couple of different modifications we made. One of them is this config, where we can load from the config the MLP expansion factor. This is the MLP layer in those transformer models. And it let us get that model small enough to where we can force it to say, okay, I don't have enough parameters to memorize this. Let me try something else. And it actually learns a function, which is fantastic. One thing that's kind of interesting is that it's really actually only in distribution training, generalization. If I try a number that was outside of the training set, so again, I went up to 0 to 9. If I try 11, it doesn't really do that well. But in total, what we're trying to show is that having the right size LLM for the task is important. Trying to make an LLM do memorization and generalization suppresses generalization. And I think this has a much bigger ramifications for robotics, where I spent a lot of my headspace in, because we don't really care if a robot can memorize, what the capital of France is. We do care if it can generalize to to the task at hand and to all unseen circumstances. Thank you.
Actually, I have a question. So this is actually a great presentation, and I think this is like nothing surprising, right? People know that like LLMs have this ability to just memorize everything and not generalize very well. Is model size the only weapon that you have in your toolkit, or like are there loss engineering mechanisms, or what else can you do?
Yeah, fantastic question. The actual paper itself, we also did like generalization techniques, sorry, regularization. So we do dropout, we do some other options. It's all in the appendix of the paper. This paper was accepted to an ICML workshop for small models, funny enough, where it was also selected for oral presentation. That's why I had the slides ready, just in case. And what we see is that when we redo the experiments with dropout, with other generalization techniques, we get the exact same results. And so it seems to be something more fundamental of, hey, when you're kind of asking it to do everything, right? So not only memorize those facts and run on the code, in pre-training specifically, it will almost just absorb everything as memorization. It's where we're trying to kind of show with our next research topic is where do we reintroduce that generalization? Is it in reinforcement learning, or is it fine-tuning, or some sort of mixture of both? But in terms of pre-training, we had many attempts. We even tried grokking. If you're familiar with grokking, where you just train it for like ever, right? We trained it for 1.5 million iterations. This is the big model. We trained all the models on grokking, and none of them actually were able to snap to that generalization. Because again, that local minimum of, hey, I get to memorize the math, because it doesn't know what we don't know, right? In a world where we don't know this medicine between Tylenol and Advil, right? How is it going to generalize to that? So I was having this conversation with someone from my team. He's like, well, what if we trained an LLM on just like equations for like pharmaceutical drugs? I was like, I don't know. But I think it's very interesting the fact that a lot of these LLMs are talked about, oh, the big ones are great. Or the big ones are, bigger models better, bigger training, scaling laws. And I think that it's lost some of the conversation of where small models can have an advantage.
Who has a question?
A two-part question. I think you've somewhat answered the first one. Is it peer reviewed?
Yeah, it's peer reviewed, yeah.
Amazing. Which means I can sign it. Second one is an A and a B. So the first A part is, during the training process, did you try to obfuscate or mask one of the number of pairs or singles in order to see if it had a biases towards numbers in general or within a certain pathway, if you know what I mean? And then the second one is, within the same framing, did you try to attempt to use words over numbers, like a literal spelling?
That's a fantastic question. I'll answer the second one first, where we immediately had the same thoughts of what if instead of the number 7, if we wrote out 7, how would that impact the differences? I will say that I imagine it would be somewhat similar. We actually first did this with just addition, and I was like, that's interesting, but like maybe it's a fluke, and that's why we introduced subtraction as well. And the same phenomenon, if only the smallest model, be able to generalize to the unseen examples, held true. So I imagine that if we try again with the word-only basis, we use that same generalization.
Fascinating. Thank you.
Yeah, I tried to sort numbers using neural networks. That was a fun exercise. It didn't work, by the way. I'm sorry. We have one more presentation, and then you can ask him your question later.
You can
sorry
find me later, I guess.
Yeah. Go ahead. Thank you again. Yep. Welcome, Sean. My name is Sean.
Databricks as a post-solutions engineer, but this is nothing to do with Databricks. I was like, started learning white coding at some point in time, a couple of weeks back. Then I'm gonna demonstrate white coding here. My background is like a data engineer, structure streaming mainly, and I work on ML components like overflow, and then I'm a starter in AI. Other than that, my academic is I'm doing my master's in computing systems in Georgia Institute of Technology. That's my passion. So I'm trying to explain a real world problem here. This is my WhatsApp. This is my school group. Like we kind of having a 25th year reunion this week. This is the problem statement I'm trying to present. Like we are like distributed all across the globe, starting from Australia to Germany and here too, and we lost in touch. So we kind of like connect together because it is a 25th year, and then people started posting how they are, where they are, they want to connect. And there was no application we have in our schools. So I started thinking of an idea of building an application. I did a full stack development during my undergrad 15 years before, and I lost in touch. So I started building one. Started as a slam book, and it's going to be our school community Facebook. So I just added few fields, asked them to upload the photo, name, where they are, where they currently work, about their families, and then add what is the memorable experience, and then save these entries along with their LinkedIn's. And this application is actually live right now, launched last week, and I did not touch a single line of code in it. I went into the TypeScript for debugging, and this is my entries. Then I looked at like, once after I built it, I looked at what are the stack it involved, because I don't know anything. So the stacks it contains like, it's built on White. Netlify is the web server on which the application is hosted. I use Postgres database called Superbase, if you heard of. And then I used to build a .io to build this application. This is a few of the prompts I gave. So that's all my application is. I have a database where I can query all the tables. I just have a single table right now to store all the data. Then I came across this group like on the person. You guys have a nice Discord channel, but I don't find an intro. So I'm planning to, if it gives 5 minutes, maybe we will try live building one for the intro similar to that one.
We don't have like that much time, but you can just give it a shot. Yeah.
Yeah, 5 minutes it takes. I took 2 weeks to build it, but I'm gonna take 5 minutes of your time to write code it and see if it works.
Yeah, try it out. Meanwhile, I mean, feel free to ask any questions from the audience. Yeah. So I have a few questions to the audience then. How many folks are new to AI Tinkerers? This is your first event. Okay, so that's surprising. So a lot of people are new, like around 80%. So that's fascinating, but also like not great from other perspective. We really have a strong community. I don't know why they didn't show up today. But yeah, welcome to AI Tinkerers. If you're not familiar with AI Tinkerers, we are a very global organization. We tend to do events like this. We just have demos and we talk about technical topics. And we're all AI practitioners, machine learning engineers, software engineers, just students, founders who are trying to just build with AI. And that's in the name, AI Tinkerers. And this is more like a forum, study group, So everyone is welcome to share what they're building, dirty white coding, things like this, your second monitor screen. And we try to encourage and foster this community in Austin. And I'm also looking for a co-organizer because I've been the only person organizing this event, and I've been doing this for 1.5 years now. And we do organize big hackathons. We had a massive hackathon collaboration with Meta, Google, and other like big companies before last year, things like this. We also collaborate with other meetup groups in Austin, AITX, if you heard of Jay Cochet, we collaborate with them. We also collaborate sometimes with other deep learning research group. I don't know if you know, they also happen in Capital Factory. They're more fully research paper oriented. If you're interested into that kind of stuff, check them out as well. AITX is more founder focused, so if you're interested in VC funding or you're interested in connecting with co-founders, things like this, check out AITX. There's also a hackathon going to happen soon, organized by AI Camp. Please check that out. So there's also a big community in Austin called AI Camp. They're also like parallel to what we do, but they have a different community. And I tend to organize these events throughout the city. So if you have any strong preference, feedback, please let me know. And yeah, sometimes we find venues in like north side of the city, south side of the city, depending on where you are, you can check them out.
Okay, thank you. Wi-Fi. I'm actually using React and Vue with database to connect.
How much does it cost in terms of programs and AI usage to build a hypersphere?
Not much. I started as a free edition on builder.io, and then I kind of exceeded the limit, so $9.99 a subscription. I canceled my Netflix. So I'm just building a entry page for this AI Thinkers meetup. So you guys, once it launched, you guys can actually enter your details and you can make use of the website. It's just a single page application, nothing much I'm gonna do. I just gave 4 or 5 database fields.
You said which are you using some sort of like a...
No, I have ChatGPT token inside.
Oh, okay.
I had already run that. And then it's builder.io.
Builder.io, okay, so that's the main tool that you're using.
Yeah, it's like a Replit actually.
Okay.
Like I was finding which one is cheaper, so and I find something.
So is it basically a Replit with the added functionality of Postgres?
Yeah, like you can add any database. Postgres is one example. And you can push your code here, like once you connect to your repository, and it keeps updated. If you don't want it and it is something wrong, you can restore to this point. And then if you want to design it, like edit it in the design, like a UI design, or you can actually very well select this block code and edit it here. And then if you want to put extra code, you can go ahead and do it. I created this page.
Yeah. So have you tried using like Codex or Anthropic? What is the Anthropic's command line utility? Forgot the name. Cloud Code. Yes. Have you tried that?
No.
Okay. Yeah.
I tried Cloud Sonnet for my work. Cloud is good actually.
Yeah, I tried Cloud Code, I tried Codex. The new Codex is really amazing as well. Yeah, just if you're vibe coding, definitely give command line tools a shot if you're into that. If you're not into that, yeah, builder.io, things like this might also work. Any final questions or concerns from audience? If not, please take pizza home. There's a lot of leftover pizza. There's some drinks. You cannot take all of those home. Okay.
I just have a question. These presentation events, like How often do you have?
Yeah. So we do meetups on a monthly cadence. So we have one meetup every second Thursday of the month. So you don't even need to, please sign up to our mailing list, but think of it in the back of your mind. Every second Thursday of the month, expect an event. Depending on if I'm available, if I have a family emergency like I had last month. Sometimes I cannot organize, but yeah, obviously. Yes, we have mailing list. It's not on Meetup. We have our own website called aitinkerers.org. And it's a very global organization. We have chapters in every major city. Yeah, SF, Seattle, like London, New York are large cities, so they have extremely good organizations, sponsors. They're very big communities over there too. Like usually we have like 100 spots and they fill up. So like it depends. Austin, we are trying to get to that level. We're not there yet. Canada, we have in Mexico, we have in like Bangalore, Hyderabad in India, like every major city you can think of. We have, I think, I don't know exactly how many locations, but we have like 500,000 members in our Discord channel.
So very quickly, if I can have your attention, we wanted to announce the winner of the Lego set so that you can take that home before you guys start heading out. So we just input all of our names into a random generator, and we got Ilya 6 or Ilya VI. She's going to come right over and give it to you. Congratulations.
Thank you. Thank you very much.
All right. Thank you once again for Comet and Google to be the sponsors. With your guys' support, we can continue to do these events. Your sponsorship goes a long way, not just for this event, but we will use your sponsorship money for other events as well. So thank you very much once again.
Nice to meet you, man. Maybe see you next time.
Excuse me, everyone. So we do have another event in this space. So I would recommend having the networking in the lobby downstairs, if possible. And we need to clear out the space as soon as possible. And if anyone needs parking validation, I have the coupons right here with me. But we need to clear out the space right now. Please take the networking downstairs. And sorry about that. Yeah.
Hi folks, there's a little bit more pizza left. If you want, please take it to your home. And we need to really clear out the space, guys. I cannot leave without clearing the space, so please. And yeah, please clean up any trash that you see and be mindful of the space. And yeah, thank you very much. I think there's one more pizza. Someone wants to take that home, otherwise we will need to throw it. right, folks. Please. Hello, hello. Mic testing. 1, 2, 3. Folks, I need you to clear out the space. Sorry about that. Please use the lobby in the hotel or outside the hotel. Yeah, thank you. I do have a veggie pizza if anyone wants veggie pizza, like a little bit leftover slice. If not, yeah, we'll throw it. Please clear out the space. A deep learning research group, Austin. Yeah, yeah. Yeah. Yeah.
Deep learning is a part of it. It's a separate company, but it's like a research lab.
Thanks, man. Yeah. Yeah, yeah. No, I got the other veggie ones. But yeah, the non-veg ones are also clear out. It's AI Tinkerers. Yeah, AITinkerers.org. We are a global non-profit kind of organization. Check us out. Yeah. Yeah, it's a recurring event we do every month, second Thursday of the month. Yeah. I'm sorry to bother you. Are you part of the AI Tinkerers or are you separate? Oh, cool. Then, yeah, I don't need to clear you up. No. I was clicking out our folks. Yeah. Thank you very much. Are you helping with something? Okay. This for 1 second. Oh, I want to take the space photo for the Oscar word. Saying that we cleaned out everything. All right, we can go home.
y'all use these now? Like, making up shit, bro. New rules now we gotta use these bags. So it's like, are you serious? I'm like, damn, they come over with new shit every other week. Then they don't tell me something done with all the bags. Now I gotta go back and change them all these. Like, are you serious? Like, dude, why can't y'all tell me when I 5 minutes? Lucky I'm doing this shit. As I mentioned, it's called asshole back. Yeah, straight up. Yeah. They see over here checking, double checking on me. First I was